So, we are in the 21st lecture, and in my last class I told you that coils will be distributed to use the surface of the machines more effectively, and if there are 3 coils which are each one is having n turns, and their the coils are one dashed here. I will draw it here. So, the coils are distributed in this way in a simplified diagram like this. I am just sketching. This is 1 dashed, 1 dashed, and then you have suppose 2 dashed. So, this is one coil, separate coil, 1 dashed, and this is 3 dashed. Okay. And if these coils are displaced by some angle, this is the angle between 2 consecutive slots, say. Okay. By one slot it has been displaced, this angle we are telling beta, and direction of rotation I have assumed like this, and then whatever is happening to 1 dash now, same thing is going to happen to 2 dash. Therefore, their phase voltages, voltage across those coils will it will lag 1 dash by beta, and then voltage 3 dash will lag by another beta angle, and so on, and the resultant RMS voltage will be this. And you now imagine all the coils are concentrated in these 2 slots. So, that 3 n turns are there here. Then these voltages would have been cophasal, and this length will be just 3 times these voltages, and you will get this one. So, this beta, all the angles will be electrical. Now, at this point, before I proceed further, I would like to tell you one very important thing, that is an electrical machines in general could be multipolar. We should be prepared for that to analyze, and then we have to distinguish between electrical and mechanical angle, that is there. The point worth noting is this, that after you are expressing everything is in electrical degree, this is 180 degree electrical, 360 degree electrical. After you are examining north south or south north, say, this is B distribution, and once again this thing repeats 360 degree electrical, okay, and this thing is repeating. Now, interesting point should be noted that beneath this distribution there is air gap and there is coils moving, conductors moving. Now, at any instant of time, this point you listen carefully, and these are very easy to logical thing, that okay, there will be conductors here, because now they will be distributed in slots like this, we will see. But the point I want to make it, these are rotor conductors, say, rotor conductors, they are moving, they are placed in slots, they are moving. Now, the statement I am going to make is that this is once again south north. Whatever is happening under a pair of pole in the rotor conductors, same thing is going to happen in the other pair of poles as well. What does it mean? That is, suppose it is moving, some currents these conductors are taking, and this is the field distribution. What I am telling, under one pair of pole, whichever conductors are present, it is expected, it is a symmetric machine under the next pair of poles, similar conductors, same number of conductors will be present and they are expected to carry current, that is true. But what I am telling, if you take a snapshot at a particular time and freeze the time there, you take a snapshot, then the distribution of the currents under this pair of poles and under next pair of poles all will be identical. Why they should be different? Whatever is happening now at a given time, so far as current distribution in the conductors, voltage induced in the conductors, their polarities, this, that, whatever is happening to this set of conductors which are under this pair of poles, identical things will be there in these conductors as well, which are in the underneath the second pair of poles. If it is a 6-pole machine, next pair of pole under that, whoever is now staying at that time, same way it will behave. Therefore, what people do is this, they always, although it could be a multipolar machine, they will always examine what is happening under a pair of pole, that is more important. If you know, what is the point of repeating that? That is why people draw like this, they draw everything in electrical degree and show only a pair of pole as if it is a 2-polar machine. And they will draw like this, okay, this is R phase coil, this is Y phase coil. We will tell about these things, I am just to giving you the idea what, and this whole angle you say this is 360 degree electrical and these coils are 120 degree apart electrical. So, all you measured in electrical terms and try to analyze the machine under a pair of poles, because nothing is going to change in the next pair of pole for a given instant of time. That is one important thing, you note that. So, a multipolar machine is often represented as a 2-pole machine and all angles are shown electrical, that is all. You analyze that, that is it. Achha. Now, coming back where I have left in the last class, that coils will be distributed or concentrated. Concentrated for many reasons is not wanted. So many number of turns if you accommodate in a pair of slots, rest of the place remains unutilized, and also here how much how many conductors you can put in a particular slot, there are restrictions on that. Space available in a particular slot is not infinite. Therefore, you have to distribute the coils, 3 n turns you want to use, you distribute it in coil 1 1 dash 10 turns, 2 2 dash 10 turns, 3 3 dash 10 turns, and they are displaced by beta electrical from one to the other. Start of each coil 1 2 3 is displaced, and if it is distributed, then we say these 3 n coils have been distributed in 3 coils each of n turns, that is the thing. Okay. Then I know how to calculate T 1 1 dash, T 2 2 dash, T 3 dash, and I find that this will be the resultant voltage. Now, I must compare. Okay, I told you, if for sake of argument, let us assume that somebody insists that okay, no, I will go for concentrated coils. If he goes, he will claim that look here E 1 1 dash, 2 2 dash and 3 3 dash, they are in cophasal and you get maximum voltage compared to this, because the sum of this algebraic sum of this plus this is less than this. Here it is as if algebraically you are adding these 3 voltages. So, I must now compare if the resultant voltage available across the combination of the 3 coils connected in series when they are concentrated and when they are distributed, what is their ratios. So, the problem statement is, and in fact, this is called distribution factor. Okay. So, let me redraw it. So, here I will draw a vertical line, and here when the coils are distributed, so the connection is same 1 1 dashed, 2 2 dashed and 3 3 dashed, and I will connect them in series, and I will examine this resultant voltage. So, this is plus minus, this is plus minus, this is plus minus. Now, these 3 voltages and the angle between 2 consecutive slots is beta. Beta is equal to angle between electrical angle, it needless to say, henceforth we will say. So, beta electrical angle is equal to angle between consecutive slots, between 2 consecutive slots, that is this one, this angle between 2 consecutive slots. What is the angle? Because it is after all round, I can calculate if it is 360 degree mechanical, number of slots present, I will suppose number of slots are 36, then 360 degree divided by 36 is 10 degree. So, I will say angle between this slot and this slot is 10 degree, but 10 degree mechanical, and what is the electrical degree? Okay, multiply that 10 degree with pair of poles. If it is 4 pole machine, then it should be 20 degree electrical. Got the point? So, number of slots are like this, it is going like this. So, the angle between the 2 slots, consecutive slots, see this center of this tooth and center of this tooth, this is also beta. If this part is called the tooth of the thing, and this part where conductors will be placed is called slots. So, tooth pitch, this is called tooth pitch and slot pitch, they are all same, that is this and this are same length. So, angle when I say the angle between the 2 consecutive slot is beta, I mean this or mean this, they are one and the same thing. Okay. So, beta is the angle between 2 consecutive slots, and suppose I have distributed my coils in 3 consecutive slots. So, here I have placed 1, 1 dashed will be somewhere, here I have placed 2, 2 dashed will be somewhere that we have drawn earlier, and 3. The start of each coil 1, 2, 3, they are individual coil, each having n turns. I will also use this slot space effectively. So, each are having n turns. 1 dash you have understood, it will be 180 degree electrical apart and so on. Okay, this we have discussed. Acha, now the RMS voltage induced in each coil, magnitude of the RMS voltage will be same, that is E 1 dashed is equal to E 2 dashed is equal to E 3 dashed, and let this be called E. Magnitude of the RMS voltage is equal to magnitude in each coil of n turns. When the coils are distributed, I have already seen that if you say that this is E 1 dashed, this phasor, E 2 dashed will be lagging this, assuming the direction of rotation this way, whatever field distribution 1 sees, 2 sees that same field distribution after a movement of beta angle. This is also beta. So, this is E 2 dashed and this is beta, and E 3 dashed will lag once again by beta, E 3 dashed, and this length and this length, these are all equal and equal to E. This is E, this is E, magnitude E, and the resultant voltage will be this one, that is E 1 dashed will be this. Now, I would like to calculate what will be this resultant voltage. Now, in this way you can go on adding distribute the coils further if necessary, whether we will do it or not, but I can tackle that situation. If this whole turns is distributed in 4 slots, I would have added another phasor here to get the resultant voltage, but more you add, you will start losing more voltages, that is the thing. Acha. Now, these angles are beta. Now, you see this is these sides are equal here. Therefore, it looks like it is sort of going to give you a regular polygon, each of length E, and regular polygon will have a circumscribing circle like this, I can imagine. It will lie on that tip of each phasor will lie on that circle. Suppose the center of the circle is here, O. Then what you do is this, what is my goal? My goal is to find out this resultant voltage, an expression of that, and resultant RMS voltage, and compare it with the situation when all the coils were concentrated, not distributed. That ratio I want to find out. So, first I have to calculate this 1 dashed resultant. So, to do this, I suppose assume the coils are distributed in 3 consecutive slots, like starting of those are like this, lengths are equal, and I know each one of them is of magnitude E. Now, what I am telling, this will be part of a regular hexagon if you go on adding further distribute, but we stop, suppose somebody has stopped it by 3. Then suppose this is the center of that circumscribing circle, which will be at the corners here. Now, what you do, you join these points. To to the center of this circumscribing circle. Then what will happen is this angle beta will be also this beta, these angles too will be beta. It will be like this. Is not, because these are two sides are equal, this angle is equal to this angle, similarly this angle is equal to this angle. So, beta minus these things you do, and from that you can easily show this is beta. Therefore, this angle subtended by each so called chord of this circle, which are equal in length, will be same beta. Now, my problem is to find the magnitude of E13 dashed. So, to do this, what we will do, I will drop a perpendicular from here to this, say this point is M, and suppose the radius of this circle, radius of this circumscribing circle is capital R, suppose. Then in terms of this capital R, this length E13 dashed can be easily calculated. How? In terms of R, which is radius, I have written that in terms of R, this amplitude E13 resultant voltage, the magnitude of that can be easily expressed. Why? Because this angle is 3 beta, therefore, this angle will be 3 beta by 2, and you know this length from this right angle triangle, this is right angle. So, from this right angle triangle, this length half of this one is nothing but R into sine 3 beta by 2, that is all, into 2 then, because this length, this plus this is resultant and these two are equal, because it bisects any chord. You drop a perpendicular from the center of a circle, will bisect that chord. Therefore, 2 times of R sine 3 beta by 2, where from 3 beta by 2 comes, this is 3 beta and this is 3 beta by 2. So, this will be the resultant voltage when the coils are distributed, and when the coils are concentrated, that means all the turns are, there is only a pair of slots here, 1 dashed all the turns, 2 dashed all the turns, 2 all the 2 turns here, 3 all turns here, 1 dashed, 2 dashed, 3 dashed, all are concentrated. So, same number of turns, all are. So, individually if this is 1 dashed, they are diametrically opposite. If this is 1 dashed, this is 2 dashed, they are co-phasal now, and this is 3 dashed. What will be this voltage? This will be same as this E, magnitude of E11 dashed will not change because of that. So, this is E, this is E and this is E. Therefore, resultant voltage in this case E13 dashed resultant of this 3 is nothing but 3 Therefore, I have been able to calculate the resultant voltage when the coils were not concentrated, that is distributed, this is the resultant voltage, and when the coils are distributed, this is the resultant voltage. Now, the ratio of these two is called distribution factor, and it is the resultant voltage when coils are distributed divided by resultant voltage magnitude of the voltage when coils are concentrated, same number of turns concentrated. You can compare only two things when they are of similar type. So, this is the thing. Therefore, K D will be equal to 2 R sin 3 beta by 2 divided by 3 E. That is the thing, is not? Now, the question is, this R is disturbing. I mean, what is this radius? Now, this radius can be related with E from a small, any of the small triangles. For example, what you will do is this: you drop a perpendicular from this to this, say call it O n. This length is R, this is R, and this angle is beta by 2, because this is beta. So, this is beta by 2. So, from this small triangle you can easily see R sin beta by 2, R sin beta by 2 is this length. It is a right angle triangle. I have dropped a perpendicular. So, R sin beta by 2 is this, and 2 times of that is this length, and this length I have assumed to be E. So, this is equal to E. So, where is that page on? So, here now I will utilize this result, that now I will write 2 R sin beta by 2 is equal to E. Therefore, 2 R is E by sin beta by 2, and that you substitute here for 2 R. So, E by, for 2 R, E by sin beta by 2, and these things were already there, sin 3 beta by 2 by 3 E, and E then goes, it becomes sin 3 beta by 2 by sin beta by 2, a very simple formula to remember. So, if you have distributed 3 coils, the ratio of these voltages, it will be a number less than 1. Okay. Only thing is, it can be generalized by telling, if instead of if there were m coils instead of 3, if there were m number of coils distributed there was a 3 here, this 3 was there. If there were m number of coils distributed, angle between them beta, then in general Kd should be then replace 3 by m. I have done for a specific number, so it will be sin m beta by 2 divided by m sin beta by 2. This is the distribution factor. So, if you know if the coils are not distributed, what is the resultant voltage you will expect out of those total number of turns. If you know the value of K D distribution factor, then you simply multiply with this. So, go through this, we will continue with this in the next lecture. Thank you.